70 years ago, Italian-American nuclear physicist Enrico Fermi asked his colleagues a question during a lunchtime conversation. If life is so common in our universe, then why can't we see any evidence of its activity out there? AKA, where is everybody? 70 years later, this question has launched numerous proposed solutions as to how extraterrestrial intelligence could be common and yet go unnoticed by our instruments. Some possibilities that have been considered are that humanity might be alone in the universe, early to the party, or quite possibly not in a position to notice any just yet. Perhaps the most straightforward answer is that while alien life and even civilizations may be abundant throughout the galaxy, the vast gulfs of time and space that separate us might as well make us effectively all alone. Here's the gist of Fermi's famous paradox. We know for sure that life and intelligent species capable of becoming great technological civilizations have appeared at least once in the universe. The proof? We're it. But the universe doesn't tend to do things just once. There isn't one star or one galaxy or just one hydrogen atom in the cosmos. When the universe allows something to happen, that thing is almost always ridiculously common, mostly because there is a whole bunch of the universe to allow it. So if life happened here once, then it means that life cannot be rare. In other words, as Fermi's argument goes, there's nothing special about us. So there must be multitudes of life forms and intelligent civilizations across every galaxy throughout the universe. And given that the universe has been around for nearly 14 billion years, there has been more than enough time for life to arise, civilizations to develop, and for those aliens to develop the technology needed to completely colonize an entire galaxy. Even if all those civilizations last for only a relatively fleeting amount of time, say 1,000,000 years or so, then out there, at least their technological remnants and ruins should be littered all over the place. And yet, we don't see anyone. No radio signals from the deep, no signs of alien technology orbiting some distant star, no ruins or remnants to speak of. As far as our observations suggest, we are completely alone. So what gives? Where is everybody? Could all our assumptions about life be wrong? Ever since Fermi first fashioned his famous paradox, scientists have proposed many solutions. Perhaps life really is exceedingly rare, and we are but a solitary example of intelligence to arise anywhere in the universe. Perhaps life is common, but there is some sort of filter that wipes out intelligent species before they grow to galactic dominance, like, say, nuclear weapons or disastrous climate change. Maybe there are aliens out there, but they remain silent, slipping through the dark vastness of space in an effort to remain hidden. And maybe our assumptions are wrong. Maybe the universe, and even the Milky Way galaxy, are far larger than we can possibly comprehend. For instance, the nearest star to the Sun is Proxima Centauri, an unremarkable red dwarf, invisible to the naked eye, sitting about 4¼ light years away from us. That may not sound like a lot, but it's because astronomers have developed the jargon term light year to hide the unimaginably huge distances between stars. Our current farthest flung space probe, the Voyager 1 mission, is right now about 15 billion miles away from us and counting. It has reached interstellar space, and it will never come back. Voyager 1 is speeding along at a solid 38,000 miles per hour. That's fast enough to circumnavigate the Earth in about 45 minutes. The spacecraft carries a record of human experiences, including greetings in 55 different languages, in hopes that some aliens will one day encounter it and know that we exist. Even if Voyager 1 were pointed towards Proxima Centauri, and it's not, to reach that star, the space probe would need about 75,000 years. Humanity developed writing only 5,000 years ago, just a tiny fraction of the time needed to reach our nearest neighbor star. But what about radio signals? Those can race away from us at the speed of light, meaning that a broadcast transmitted from Earth could reach the Proxima Centauri system in just over 4 years. But while we can guarantee that a radio signal can get to our neighbor's star in a decent amount of time, we cannot guarantee that it will be intelligible. Radio signals, like all forms of radiation, weaken as they travel because the signal gets spread out over more and more area. And human broadcasts aren't the only source of radio emissions in the galaxy. Exploding stars, vibrating charged particles, and even interstellar dust clouds all emit their own very loud radio signals. By the time even our most powerful broadcasts, the radio emissions that can be heard loud and clear across the globe, reach Proxima Centauri, they are so weak that they can no longer be distinguished against the general galactic background hum. Proxima Centauri is our nearest neighbor, at a mere 4 and change light years away. The entire Milky Way galaxy spans over 100,000 light years in diameter, and in that volume houses a few hundred billion individual stars. Billions of cities could be out there. It's hard to wrap our minds around a few hundred billion of anything. Imagine an advanced alien civilization that develops some fantastical technology that would break our current conceptions of physics. Say that they use that technology to colonize star system after star system, hopping across the void and spreading their influence. Let's say that they colonize and inhabit 1 million star systems. Keep in mind that there are roughly 10,000 cities on planet Earth, and for this intelligent species, we're talking about thousands of cities per world on 1 million worlds. Now think about this. 1 million star systems represents less than 1,000% of all the stars in the entire Milky Way galaxy. An alien civilization so advanced it's incomprehensible to us, so sophisticated and long-lived that they can spread themselves to 1 million worlds, doesn't even count as a rounding error in our count of the number of stars in our galaxy. The universe has vast gulfs in space, gargantuan numbers of stars, and lastly, immense expanses of time. Our universe has been around for nearly 14 billion years, and the Milky Way galaxy formed at least 9 billion years ago. Civilizations that rise and spread and thrive for hundreds of thousands, even millions of years, live for just a blink of an eye when counted in cosmic time. Humanity founded its first cities only a few thousand years ago. Intelligent alien species that last way more than that still aren't even worth mentioning on the great cosmic calendar of our universe. The cosmos is big, far larger, far grander, and far older than we can possibly fathom in our Earth-grown brains. And this may be the simple yet frustrating answer to Fermi's paradox. There could be dozens, hundreds, thousands of intelligent alien civilizations out there, living on a host of worlds with a technological level meeting or surpassing our own. And we won't ever see them, or hear them, or meet them. The distances are just too great. The stars are just too numerous. The galaxy is just too old. Fermi was probably right. We're likely not alone in this universe. But Fermi missed something in his estimates. The universe is also gigantic, making us effectively alone. With this cosmic isolation comes bad news and good news. The bad news is that we'll likely never encounter another intelligent species, except perhaps for a rare and fleeting glimpse at a stray radio transmission someday in the far future. The good news is that every star we see in the sky is unclaimed, empty, and waiting for us to reach out and explore it. Thanks for watching.